Okay, I guess we'll go from the top here. Okay, number one. On one hand, there were 142,763. Okay. On the other hand, there were 228,014. Okay. How many more? Okay. I assume you're okay with this one. Yeah. Make sure you know which one is the bigger of the two, and subtract. Yeah. And then subtract. Okay. Now, what about two? The whole batch cost this much. Okay. 28,000 and contain 140 items. Okay, right. Okay, this is the one. Let's do it. All right. How would you do it? Write the two rates ratio implied by this statement. Okay. All right. And then you use that to solve what would be the price for 200 items. Okay, good. All right. What do you think? What do you want to do?
$28,000 over 140 items, and then 140 items over $28,000.
Good. Is there something more you can do? I'd like to know. Let me get my thing a little lower. So I got what you said. So, but like this, I don't recommend you put the comma until you get the answer. This is what you said. Good job. But let's do dollar here, and then let's say 40 items here. But tell me again, what do we do next?
And then it's 140 items over $28,000.
Okay. And then what do we do?
And then you do 28,000. You do 200 items times $28,000 over 140 items.
Okay. Now, I'm sorry. One more time. Which one? Which one are you going to use to solve?
28,000. 20. Yeah,
Okay. Good job.
$28,000 over 148.
Okay. Good job. Now, so you think you want to go at it like right away? I guess it's okay if you use the calculator. Do you want to see what if you want to do it's cleaner? Okay, let me see. This thing. What I mean by that is, what if let's test this out and you see what we can do with it. So 28,000 divided by 140. So I get 200. Look at that. What's so special about that? What do you think? Now, so it's 200. Okay, we're gonna get 200 out of this. But then, what is the unit? I think you wanna write that. Do you know why? Now ignore the 200 items. Okay, well, I'm not talking about that. We're not doing that right now. It says write the two rates or ratios. That means I don't believe you actually can stop there because it's actually reducible. Yeah, you know what? One thing it does not say is the unit price or unit rate. Get it? So therefore, it's technically okay. But let me give you another option here. If you were to rewrite this to make it cleaner, it would be $200 over one item. Do you get this? Let me see. Pretend you actually, use the calculator and test it out. So this literally means the same. That means it's actually much cleaner to use, right, than the other one. Because the other one, you have to hit the whole thing in the calculator. There's a lot of type pressing that could be liable to make a mistake, right? Yeah, think about that, okay? So I recommend you do that. I think you may want to save that as one of the rates or ratio, and then this one. Okay, let me see. What do you think this is going to turn into? When pretend you reduced it or make it look like that. Let me see if you're okay with. I'm not going to say much. How would you change that into something smaller? How would you rewrite it? The hint is up here. What do you think? You know how? Are you okay with this? Reduced to that, right? But do you understand the one item? Remember the unit rate like you used to do before? Okay. Then how would you rewrite that? Pretend you use the calculator again before you actually move on. Time or use it to, solve.
Um,
Yeah, there's something about this that you may want to learn. I think okay, I'll show it to you. If I want to simplify this, I can say that, hey, did you see the calculator? I can divide 140 into 28,200 times, right? Did you get that?
mhm.
That means you can do that. You can reduce it exactly the way you've done it, but keep the units. It'll be one here. It'll be $200 here. One item out there. Therefore, this is equivalent to one item. Yeah, let's do singular here. $200. One item for every $200. So there you go. This may be the answer that they rather you write down. Like for the first part of number 2. See that right there?
Mm.
And then we'll use this one right here to solve for, like you said, I know you want to use this, but I recommend if you already use the calculator, might as well just go with this. Let's just say you went and simplified and you want to use that. You can. So let's times that by 200 items. You get that? So that means I think this is what you wanted to do. So you can do X, okay? X here for multiplication. It's up to you. Then the item cancel. Then your answer is 4 and 4 zeros. Is that okay? Then you can put the comma. I hope you're okay with that. Wait, is that right? What would be the price? Yes, that would be the price. Yeah, we got the items out. Yeah, good job. All right, number 3. Do you see that? This is maybe the best way to do the work and show the work. All right, what about number 3? So, okay, what was the average number of tons of bricks sold during the 4-month period of March, April, May, and June? Okay, so how do we do that? It's the average, okay?
So if it's March, April, May, and June, so March is 260.
Okay,
April is 200. May is 300, and June is 240, and then you average it.
so we're gonna do the way that we've been doing, right?
Mm-hmm.
Okay, good. What are we gonna divide it by?
4.
Right, good. Okay, I'll let you do that. Okay. Now that would be the average for the first or for the 4-month period. Okay, good. What's the unit of this one?
Bricks.
Okay, good. Very good. All right, number 4. Okay, what do you think? The average time for the 4 races was this much. Okay, there's something fancy about this one, right? If the times for the first 3 were these 10.1, 10.6, 10.3 seconds, well, what was the time for the 4th race? Now, like I said, this would be so easy if we, do it algebraically, but we're going to go by the way that your teacher wanted. I'll show you after how it would look like. We're not going to solve it. I've shown it to you before, but I'm going to show it to you again. Okay, what do you think? How would you do it?
So
It's similar to the ones that you've seen before. That you've done. Let's see if you remember. Yeah, the algebra would have been so much easier to understand and remember, and but we'll do that. We'll do that. I'll write it out, but we don't have to solve it. But let's do it the way that your teacher want it.
So it's 10.2
Mm-hmm.
times 3.
Is it 3? Why is it 3?
Yeah. Because if
Why
it's
3?
the first, because it's the first 3 races.
Okay. Well, good guess. But it doesn't say that. It says the average. We have to go verbatim also. We're going to
Oh,
analyze
so
that a
it's
little bit. Wait.
10.2 times 4.
Yeah. Do you see why it says right there, the first statement? See? We're going to go by verbatim. We're going to go exactly. So yeah, think about it. Okay, it makes sense. It even tells you to do that. The average time for the 4 races. So we're going to times it by 4. Right, whatever. Let me see what that is. This one I will continue with. 10.2 times 4. So it's 40.8. So what do we do with that?
And then we add 10.1, 10.6, and 10.3.
Good job. 10.1 plus 10.6 plus 10.3. Okay, good. Very good. So what is that? 10.1 plus 10.6 plus 10.3. Okay, so we got 31. What do we do with that?
And then do you multiply them
No.
or subtract?
Okay, subtract. If you multiply them, sometimes when when you do this on your own, you don't forget if you multiply this, it's going to be a huge number. You can tell. So therefore, something's wrong because if you want to make sense of what the answer is about, right? It says what is the fourth race time? That would be too much. Get it? Because the average says is wait, sorry, yeah, is that right? No, the average is this right here. That's why. So it can't be like a huge number. So yeah, we subtract. So 40.8 subtract 31. If your teacher wants you to show the work and align it, go for it. I'll do 1 decimal place right there. And what is that? 9. Okay. So that looks like around 10. So that makes sense. Is that okay? There you go. Seconds. All right. All right. Tell me what would be the next page you want me to look at. Let me go ahead and flip it for you to see.
There's still one more in the bottom.
Oh, thank you. Oh, man. Okay, don't forget oh, yeah. But if it's something that you can do, then we want to do as many as we can. So what do you think? Okay, so I'll stay with you on this one if you're not sure. What do you think? It's a surface area, okay?
So you have to find the area of all the sides. So you do
Okay,
30 times 5, and then you multiply it by 2 for the 2 sides that it's on.
okay. Good job. I'll write it this way. You may want to do that times 2. And what else?
And then you do 15 times 5 times 2.
Try to write it this way. So it's like a punctuation that we are learning, like how to punctuate. Okay, that's good. Now we got the sides. Now what? So I don't know. You can make a note here. Sides.
And
What?
then you do then it's 30 times 15 times 2.
Good job. What top and bottom? Yeah, you got this. Top and bottom. All right. And then we add them up, right?
Yeah.
So let me see. 150 times 2, that's 300. 15 times 5, 45 times 2. Is that right? No, it's not 45. 75 times 2. What is that? 150. And then 15. $450 times 2. That's what is that? 900. We add them up. Okay, I'll double check with the calculator. 300. 15 times 5. 75 times 2. Oops. 50. And 30 times 15 times 2. Okay, add them up. 900 plus 150. I'll do it with you. But then tell me what the final unit of this one.
It would be meters squared.
Good job. Oh, yeah. Very good. Okay, so here's your final. 1350. Is that meter? Yep, meter squared. All right. Which one? Which page next?
It's the next one. There was only 2.
Okay, that sent me a lot, by the way. Maybe I was looking at the old one. Is this the next one?
Mm-hmm. Yeah.
Okay. Let me see. I'll scan for what I think it's going to be challenging. Okay, let me see. Okay, it's the tent. All right, let me bring in. Where's the tent one? Okay, so I have to bring it in. Sorry. Nope, not that. All right. I don't know why. Okay, I see what's up. The background is. All right, okay. All right. I believe this one was a little tricky for you last time. But tell me, number 6, how do we do it? I'll let you.
You do 20 times 10.
Okay, sorry. It's the volume, right? Okay, yes. So we're going to do volume of this tent shape or the top of a roof or house. So you said 20 times 10, and then what?
And then so if it's 20 times 10 and then 10 times 41.
Okay, not quite. Do you remember what the volume formula is?
Oh, so it's 20 times 10 divided by 2.
Okay. And then what?
And then you can cross cancel.
Okay, but do we do more than that before we cross cancel? Okay, let's review. Okay, like volume. I think you just used V, and they use capital B in general. But this part here, the H could be lowercase or uppercase. But now this is about now the volume of this one is it's for generic. It's a generic volume formula for any solids. You know what I mean? Like the one that 3D prism, like prism shape. So this one is a triangular prism, if you want to be technical, right? So it's the face. The base is like, okay, now if I were to stand it up, this could be the base. This could be like the height. You see it? I'm standing up that tent. This could be the height, but the base is this whole thing right here. Get it? Like the base is on the bottom there. the base is the area itself. The base of this is the volume. Okay, I'll write it all out here. So the volume of this particular triangular prism, it would be this. The base is now it's base times height divided by 2 on its own. So I'll lowercase that. It's a triangle, right? The face, and then times the height, which is going to be the depth, like right here, 41. Do you remember this? So times like the height. So I'll be consistent with that height right there. So this is it. So it'll be what you said, 20 times 10 divided by 2 times 41. Do you remember this? Right? You see it?
Yeah.
Okay, now we can do cross canceling or anything that you recognize. You can do 2 into 20 or 2 into 10. You want to do 2 into 20?
Yeah.
10 times. And then 10 times 10 is 100. Then 100 times 41 would be 4100. Put a comma if you want on this one. But what is the unit?
Centimeters cubed.
Very good. All right. Volume. Yep. Very good. I hope you're okay with that. Yeah. It has to do with, let me explain, okay? Like, I never actually get to help you visualize the volume of like things that seem to be 3D solid, even cones, even, well, not quite yet. The cylinder, for example. For example, for this shape, it'll be something like a triangle, a bunch of triangles that's stacked on top of each other. Can you imagine that? But but no gaps in between, okay? But like cylinder. So what you do is that you find one slice and then times by the depth or the height. Get it? If I think you'll be doing cylinder pretty soon, like a shape that looks like a rod. You can think of a bunch of CDs stacked on top of each other. Get it? Like that. So you find the area of the base. It's a circle. Pi r squared, like 3.14 times, r, the radius squared, and then times the height, the depth. So that's how you could kind of imagine it. I think this is the best visualization. I mean, you can actually see, or so that you can memorize. I mean, you can remember, right? So that is the way I would recommend you think it, because you're gonna have to find like the face and then the depth or the height. You have to time it for it to be a volume. So you can't stop right there. Like the face. That's when you were saying this. So you stop that. You will stop there. It's only one layer, like just a face, but you didn't get the rest of it, like a bunch of slices. Can you imagine? So this is the triangle, the face, but that's not the volume. That's the area. Therefore, you got to get a lot more. To do that, you just times the depth of it, how thick that is, right? Like right here. Okay. Now let's have a look at this here. Let me see. I believe you're pretty good with these ones. Tell me how to do number 7.
So if it's what number is 5/8 of 168, x equals 5/8 times 168 over 1.
Good job. Now, if you're my other student who are not at this level, they would actually do division. But let's do it the way you said it. This is exactly right. So x is what number? It's the number, okay, times. I recommend you write the parentheses like this, okay? You can do dot, of course, but I recommend you get used to the parentheses, writing the parentheses to emphasize the multiplication. Let me see if so it does go into, could you tell 168 is divisible by 8? Like we're going to cross cancel.
Yeah.
Because you see the first 2 digit is 16, the last one is 8. It will go into it. For example, we're going to 16 2 times and 8 1 time. So it's 21. Okay? 21 and 8 1 time. Okay, I'll lower it. And then just times it. 5 times 21 is 105. So that should be the answer. Is that okay? Yes. Actually, I said it wrong. It's just multiplication straight, not division. I think I said it because it's not this one. you you have a fraction and off and a number right immediately right after you multiplied. A fraction of a half of 100. You know, how do you get 50, right? You know it's 50. You multiplied or you divide it by 2 if you cross cancel. I think you're good with that. Okay, let me see if in this one, let's look at number 8 and even 10, but I don't remember doing this one with you, but let me see. This is the one that you'll divide if you don't show any work, but I think you're supposed to set up an algebraic equation. Let's do it. How do we do 8?
So it's 4/5 times x equals 7/2, and then you have to multiply it by the reciprocal.
Good
So
job.
you
That's it.
cross out, yeah, and then
Good job. Let's do it. So it's like this. Now, this my student who will not be doing algebra yet, he would be taught to divide, or she would be taught to divide seven halves by 4/5. Can you imagine that? Same answer. You know that, right? It's the same thing as, if you were to divide. But if you were to divide, you have to flip-flop and multiply anyway. But you're doing the algebra, therefore you skip the division part. I think you're okay with that. I think you understand that. So here's why you want to don't use X here. You can do parenthesis, you can do dot, like that. Dot over here. Right, there you go. Nothing cross cancel here. 35 8. Now you can leave the answer like that because you see number 8 came with the improper fraction as well. So you can stop there.
wait,
Okay, I
is it
think
38 eighths or
30,
35 eighths?
35. Thank you. 35
Because I
8.
got 35. I thought.
Yes,
Okay.
good job, good job. All right. Right, that's a mixed number. I think you're good. What decimal part? Okay, this one, 12. What decimal part of 33 is? Okay, what do you think about that?
And then it if it's what decimal part,
Mm-hmm.
it's this x times 33 equals 0.0066, and then
Wait.
so
Tell me again.
x times 33 equals 0.066 or 0.0066.
Okay, that sounds good. X times 33 equals 0.0066. Is that what you said?
Yeah.
That's good. Very good. Now, obviously, you could also write it more standard, like 33x. Is that okay? But no big deal. It's okay. Now, there's a decimal here, and there's a dot here. You see why parentheses may be good, like that? Yeah. I recommend it. Don't mix and match. I recommend if you are dealing with a decimal number, parenthesize it so that if you are multiplying in the in the equation or in the steps, then divide what's out by 33. Okay, that's it. Whatever that is. Should be like 0.00. Okay, that it's the same thing as 0.0002. Is that okay? So let me give you have your calculator with you. So okay, I'll do a placeholder 0.0002. That's the answer. Okay, let me think. Yeah, you're pretty good with these now. I'm very impressed. However, there are versions of like what percent. Have you guys gone over that? Like what percent? With this.
Yeah.
Okay, I guess I'll wait for that. But that's going to be the variations of these 7 to 10 or 7 to 12. Yeah, number 7 to 12. Okay, very good. Now, again, I believe 16 and 17 maybe something you want me to go over. Do you see that?
Yeah. It's order of operations.
Mm-hmm.
Yeah.
How's that for you?
I struggled with it before, but then now I'm good with it.
Okay, good. Now let me kind of like help you with speeding things up. Okay, you don't want to add, don't want to subtract
Yeah.
yet, right? You want to work around them like this, get that. So watch, if I do things simultaneously, let me see why my ink is thick. It'd be like 12 here and this here. You can do the multiplication from left to right. 18 times 7. I recommend you do like 18. Oh, you can parenthesize it to make it consistent. 7 right there. Then over here, 4. 4 times 3. Do it, do it in the parentheses first. Order operation. There you go. And then you could, I don't know, go another step. I'll go down this way this time. 70 plus 56, 120, 126, and then 12 here. And a minus here. But look at this problem, okay? There's something special about it. If you see this, right, I believe you're probably going to get to this step eventually, right?
Mm-hmm.
Now, what would you do next? I have a reason.
You have to add first 12 and
Okay,
126.
okay. So here's the deal. There's nothing wrong with that. But you wanna think, is there any other way? Any other way? Do you have to add first? Okay,
Yeah.
okay.
My
There's
teacher
not.
said it's because once you get to only adding and subtracting, you have to go left to right, or else it will be wrong.
Okay, if he said exactly that he would be wrong. Okay, let me prove it to you. But before I do, when you finish your multiplication, like before adding, subtracting, okay, think about this, okay, before you, yeah, you got to this point, you're done with, pretend there's even division. You're done with all of it except adding, subtracting, right? I'm double checking my 18 times 7. Okay, anyway, okay, I'm right. Now, let me explain. Yeah, if he said exactly that, he would be wrong, or she would be wrong. Because once you're done with multiplication and division and you're only left with adding, subtracting, you're in this particular property now. You can do associative property of addition or subtraction. That means you can actually switch it any way you want. You can do any order you want. But be careful, okay? This minus, it will be literally in front of 12 always. Okay. So if I were to do this problem, right? Now trust me, this is the way you want to go, because I know you're following your teacher, but you have to be flexible here because I'm right. I'm not saying I think your teacher meant to say something different. Okay, but I think you remember it. You remember it differently. That's all. Okay, I'm pretty sure your teacher knows, but I believe he didn't met, or she didn't meant to say exactly that way. But you remember it that way. Yeah, it is true for multiplication and division, but when you're done with them and you're actually doing addition, subtraction in like in a series of numbers, right? You're allowed to combine any two you want, but be careful when you have a subtraction. You can think of a negative 12. Is that okay? Like add, like, so what I would have done is this: I would combine those. Okay, when you combine those, it's faster. Why? Because they go to zero. It's gone, right? 12 minus 12, or 12 plus negative 12, they're gone. Your answer is 126 is what you have left. Now I'll prove it to you. Now, this has always been done. Your teacher knows this, but I'm sure you kind of like remember it differently. Okay. But I know your teacher knows it. Guaranteed. Yeah. She would not be, teaching, right now if she does not know that. Okay. So the answer is 126, but let me prove it to you. Let me go and punch in calculate. Let's do it like from left to right, the order that you want it. It's still the same answer. Here we go. Take a look. So we're going to do 12 plus 126. Okay, I'll do two at a time. So it's 138. Then I'll subtract 12 from it. Get it? So I'll take a look. Then I'll subtract 12 from it. Oh, it's the same answer, 126.
Yeah.
That means,
I
yeah.
remember I remember you telling me something like this, so then I did it, and then my teacher said, that's wrong. It has to be left to right, or it's going to
But
be wrong.
but the thing is that, did you do it for this problem or you did it for something else?
No, it was for this.
Well,
And
you
they
see
said
why the
that,
answer is right.
yeah.
Okay, now I know why he would say that. Now, I'm not going to be too critical. You teachers basically want to feed his ego, right? I'm your teacher, you listen to me. Get it? So that's the thing. So we're going to go by your teacher because you want the points. But keep in mind, you can do this when you're no longer in his class. Think about it, okay? Please think about it, because this can save you time a lot, and especially when you're at high level. So your teacher is not being very mature about it, okay? Because if he or she were actually, you got to think about it. Some student will be a scientist and engineer. Your teacher has to be flexible and actually learn to actually adapt and actually be mature about it. Hey, okay, I'm sorry. Yeah, you can do that, but you have to explain it. But yeah, go by your teacher's way. I can prove this all day long. I can we can look at do another problem with, everything's done except adding, subtracting. You understand? I can prove this all day long. Yeah, your teacher want to, hey, I'm your teacher, and you listen to me. So that's his right now mentality, right? His thinking. So don't worry. Just, yeah, go ahead and do what he does. He wants you to do. All right, let's do 17. Because it's still also doing order operation. But please be open-minded. Think about how I showed you this, because you need this for later math. Trust me, okay? There's so much intense math that you're gonna do, and you have like the arithmetic part. Like this here is like the arithmetic part that is involved. You have to speed things up so you can move on to the concept. Like you have so much higher, more difficult concept up there. So if you can't do something fast, like this, you might not be, you may not have time to check your work after you finish, before the test or quiz. Okay, think about it. Okay, all right. Let's do this here, right? Parenthesis, order operation, PIMDAS. So here we go. It'll be 3 plus 1. I'll work upward. That's 4 in the parenthesis now. So you're left with 5 times 4. Okay, I'll put it up here, and then I won't touch the plus and the minus. I'm talking about that. I think you understand this is going to be like a group, a unit, right? You got to do them first, right? Before the main adding, subtracting, these two are later. You see that? Are you okay? The plus and minus, yeah. So this is going to be 36, and this is going to be 10.
Yeah.
Okay. So, and then I'll go one more step. This is 20. And then we're going to add 36 and then minus 10. Am I right?
Mm-hmm.
Okay. So let's do the order he wants it, but I'm going to actually do it another way, which is I recommend you do. For example, if I were you, I would do this. I'm not going to always do this. I'm not always do the first and the last or anything. It's not that. But it happens again that this is easier. You see, why watch? If I do this right now, I get 10. Then, therefore, the answer is 10 plus 36. The answer is 46. Get it?
Mm-hmm.
Do you see that? Yeah,
Yeah.
but I'll do that. I'll do that later. Let's do your teacher's way. Oh, yeah, I'll do that. Okay, I'll add. That'll be 56 here. I'll work upward, okay? 56 minus 10. What was that? Oh, the answer is the same. 46 I said a moment ago. There you go.
Mm-hmm.
See? Now you see. Yeah, sorry. Lame. But I criticize teachers all the time. But especially right here, your teacher's not thinking, straight. Yeah, he should be actually thinking about some student will have to be able to do things fast for, their future career, possibly, right? No, he's not thinking that. He just want to feed his ego. That's sad. Sorry. Anyway, all right. I think this one you know how to do. You'll be doing this. There's only one operation left after that. So I know you're good with that. Same thing. I would recommend you convert that into improper fraction, right? And then multiply. Everything looks good. Now here is where you want to kind of go in order, right? Do PIMDAS is like, hey, PIMDAS. Let's take a look. No parenthesis, no exponent. Here's multiplication, addition, or subtraction, right? Yeah, I have said this. Like you can do multiplication, division. I recommend you do whichever comes first from left to right. Yeah, I did say adding, subtracting, whichever. but but there's but this is just like a rule that will help student remember. You know what I mean? So it's not like set in stone, and there's nothing else you can do. The adding subtracting, if you're done with multiplication division, you can always add subtract any way you want. But again, make sure the minus got in any problem will belong to the one right after it. Okay, from left to right. This minus, it's going to be attached to that number, like a cube root of 8. Oh, I want to talk about that too. So that means you want to do this first and then flip flop this one to multiply. Get it? After you convert it into improper fraction, all of it. Okay, now. Hey, we didn't do, how do you do these here? Let me kind of back here.
So the cubitive of 8 is 2, and the cubitive of 27 is 3.
Okay, how do you know? That's right, by the way.
Because 3 times 3 is 9, and 9 times 3 is 27. And
Okay,
then
good.
2 times 2 is 4, 4 times 2 is 8.
Good. So you're looking for a number, when you're doing cube root, you want to look for a number that time itself 3 times will give you that, number inside, right? Good. All right, and then this is going to be 9. So it's plus and minus. Okay, so let's do that again. I'm trying to actually feed my equal. Here we go. I'll do it in order you want. But okay, here's like what is that? 12? 12 minus 2. That's a good number because you get 10 out of it right away, right? See it? So the answer is 10 here. 12 minus 2 is 10. But take a look. If I combine these first, I get 1. 9 plus 1 is faster, easier. Okay, same thing, 10. Have I proven my point like 3 times, different times? Therefore, your teacher is not, yeah. You see, but just go ahead and do what he wants, so that you want the points, you want the grades, right? You want, yeah. So follow his, yeah. But then you see that this is actually can be done, so you can actually use this later on. I'll bet anything he's probably not going to check all your work, let's say on the test anyway. Yeah, if I were you, I would do this first because it's easier on my eyes, right? That's 1, and then I'll add that 9 to 1. I'll get my 10. There you go. Now this is nothing, but it's something that later on it get more lengthier, and you might want to consider doing it. Yeah. Okay. Everything else, I think you're good. Oh yeah. You know what? We haven't done scientific notation for a while. And the two unit multipliers, I think you're okay. I think, right? I'm pretty sure you're pretty good with this. But wait, what about scientific notation here? 29. Let's do A and B. B is easy, I'm sure.
So it would be
Do you remember the form of scientific notation? Do you want me to write it out, or do you remember the format of it? It looks something like this, right? Times, you can have as many digits behind the decimal here, times 10 to some power. So this is your scientific notation. Okay,
so is
the
it
form.
98,213 times 10 to the third power?
No. So I'm glad, because we haven't done this for a while. So look at the format of this scientific notation, okay? Note. Okay. Side note. Scientific notation. Actually, I'll write. Okay. Now, look carefully. You're allowed to have 1 digit in front of the decimal, and you can have as many right behind it from left to right, okay? And then times 10 to some power. So therefore,
I get it. So then it would be so it'd be 9.8213 times 10 to the 7th.
good. Yeah, you got this. It is 7th power. That's it. Because if you place it here, you have to move it all the way to the back. How many times, right? Yeah, 7 times. Yeah, you see it. 7. 1, 2, 3, 4, 5, 6, 7. But the comma helps. You can see it. The 2 commas help. That's it. Okay, it comes back to you. I know. Just keep in mind so you don't forget. Now, how would you do B then? Do you want to write it, into a standard notation, but a regular number? Do you remember how to do it?
So yeah, if it's 10 to the negative 5th, you move it 5 decimal places to the left.
Good job. And then or whatever you don't have, do a 0 placeholder, right?
Yeah.
4, 5. That's it. So it'll be 0.0003207. Let me double check.
Yeah.
1, 2, 3, 4, 5. Yeah, that's it. You can do a placeholder 0 out in the very first, in the front, first digit. Okay, that is good. Oh, are you good with 30? I think.
Yeah.
Yeah. But we'll do it when I'll do it next time. But I think you're good with that, just to be sure. All right. If there's anything else, yeah. So do the improper fraction, and then flip flop the bottom one, and multiply it. Okay, anything else? I think you're good, right? That front page is. You don't have another page, right? These are the two.
No.
Okay.
That's it. Yeah.
Okay, good. Okay, so can I ask? I'm actually really curious now. So if you do 21, so you're saying you gotta do this, like you want to do that, right? First, and then whatever you get, you subtract it, right? Is that what you said? Is that what you think? Guess what? You can also combine this first if you want, and then add that. No kidding. Okay, do you understand? I'm proving my point already. But just be aware if you scan from left to right, that subtract it has to be in front of that forever until you combine it, until you use it. Okay, like minus 3/4, it's going to stay right there in front of it from left to right, in front of 3/4, in front of 7/30th, in front of 81.34. You can add a negative. You can treat it as an integer, but this is a decimal. But okay, whatever. But I think you understand. I think you understand. So yeah. All right. I think that's good. Huh?